This video is about a concept in math called slope. Let's say I was walking along a nice horizontal line like so, and I came upon a slight rise, maybe a little hill or something in the way, a little pathway. So there you are walking, no big deal, just walking along. Or perhaps you come upon quite a big rise and you think, oh my goodness, I might even have to get some rope to get up here. I might have to crawl a little bit, get some help. Right? It's a lot steeper. One is much steeper than the other. So we can look at these two things basically as walking a line. I have one line that looks like that, but I have another line that's much steeper, right? This measure of steepness is what we call slope. It tells me how steep a line is. Now, of course, we could also go the other direction, right? We could come back down this side of the hill, or maybe down this side, and again, one is a little bit steeper than the other, right? The main thing to remember in mathematics is that we slide down this one. Is that we always go from left to right. So in math, we always move on a graph from left to right. You can think of mathematicians as being very positive people. We head towards the positive x direction, right? Always. So we never turn around and go back. We always keep moving forward. Okay, let's look at this idea of slope on a line and look at some of the equation for it. Okay, we have a line, and I want to go from this point, point 1 in pink here, to point 2. Now remember, this is on a Cartesian coordinate system or on a grid. Alright, so I can't go just directly along the line. I have to go along that grid. I have to go, in this case, I could start with 1 and go up 1 and then up another unit, and then I could take a right-hand turn and go 1, 2, 3, 1, 2, 3, 4 over to 2. We could do that. We could go up and over. And why would I want to do that? Well, I'd want to do it rather than going x and then y. I want to do it because slope, one way of thinking of slope, is rise over run. So I've risen 2 units in the y direction, and I've run over 4 units in the x direction. So I've gone up 2 and over 4. Again, we're always moving in the positive direction. That's great. So that equals 1/2. That's our slope. So slope is a real number. Let me put some points to this and we'll take a look at the equation. Alright, so here are the ordered pairs, our coordinates of each point. And again, we're going to go from this first point, minus 2, 1, to the second point, 2, 3. Slope, we said, was rise over run. Another way to think of this is the change in y, how far we've gone in y, the change in y, and I use the symbol delta, delta y, over this little triangle, delta x. Right, the change in y to go from this location to this location, this distance in y, is just the difference in the y values of the points. So I'm going to use subscripts here. I'm going to say it's the second point, y2, minus the first point's y1, all over x2 minus x sub 1. So let's take a look at these points again. This we said was the first point, minus 2, 1. And remember, points are x comma y. So I'm going to call this, since it's my first point, x sub 1 comma y sub 1. And since this is my second point, 2 comma 3, remember it's x sub 2 comma y sub 2. And it's often a really good idea to go ahead and label your points. All right, so let's just plug those into our formula here. y2, well, if I just go up here, 3 is y2, and I subtract y1, which was 1 in the point, and I put that over x2, which I can, since I've labeled the points in my graph, I can easily see what x2 is. It's 2. And I'm going to subtract x1. x1 is a minus 2, so I'm subtracting a minus 2. Right, so this comes out to be 3 minus 1 is 2. 2 minus a minus 2 is 2 plus 2. So this comes out to be 2 over 4, which is 1/2, which we knew, because that's what we got before, right? We got 1/2 up here. We get 1/2 again, as we should. Great. All right, here's another example. Let's find the slope of the line through these 2 points, through the point 1, 4, and the point 4 minus 1. Now I know that slope is rise over run. And rise goes up and down, and the axis that goes up and down is the y-axis, so it's delta y. The axis that runs back and forth is horizontal, it's the x. Alright, and then the other thing I know is that the change in y is just y2 minus y1 over change in x, so it's x2 minus x1. So there's my formula. Easy to remember if I remember rise over run. Alright, let's go back at these points. Let's take a look at these points. And I find it really helpful to label them. I'm going to call this x1 comma y1, and I'll call this one x sub 2 y sub 2. That way I have my first point with the subscript 1 and my second point with the subscript 2. That way now when I go into the formula, it's really quite simple. I just say, all right, well, what's y2? y2 is this one. It's a negative 1. Then I'm going to subtract y1. y1 was a 4. Okay, so I'll subtract 4. Then I go to x2, which is 4, and subtract x1. x1 is a 1. All right, let's see what we get. Minus 1 minus 4 is minus 5, and 4 minus 1 is 3. It's negative. Well, let's plot it. Let's see what this thing looks like. Get a general idea of what these points look like. So I have 1, 4. So 1 goes along. Let's put this x and y. 1, and then I go up 4. 1, 2, 3, 4. So it's over 1 and up 4. That's my first point. Then my second point is x is 4. 1, 2, 3, 4, right? And y is a negative 1, so I'm down, here's negative 1, I'm down here. If I join these 2 points up, going from left to right, notice I'm going downhill. So when I travel left to right, I'm going in a sort of negative direction, right? Hence this negative sign, or negative slope. So now we can see that slope is not just giving us an indication of steepness, it's also giving us an indication of direction. If we take a coordinate system, put a line on it that goes up like this, I know the slope of this is positive. If I have a line that goes in the downhill direction, I know its slope is negative. All right, another way of looking at slope is to think about an idea about how quickly values are changing, and sometimes we think of this as a rate of change. So let me put some grids up here, and I'll be talking a little bit about money here. Okay, here are two graphs that have money on the y-axis, and you put a certain amount into say an account. This is year 0, and over on the right this would be year 0, the y-intercept, right? So you say put $100 in. All right, now let's say these are years. 1, 2, 3, 1, 2, 3. Which account would you prefer? Well, yeah, I'd like the one that's a little steeper. Its rate of change, the rate the money is changing is much faster on the right. And so we can think of slope as a rate of change. Right? The change in money, in this case, the change in dollar value, right, over the time, how many years? Change in dollar value over years. And we'd like the one that's bigger, right? And we'd certainly like the one that's positive. I wouldn't really care to have my money put $100 in and have it do this, right? That would be bad. Okay, so sometimes we talk about rates of change, and when you hear the word rate of change, what we're really talking about is slope. Good.